Hello class, this is Mr. Hart, and in this podcast we want to continue our discussion of motion. And in the previous lessons we've been looking at the kinematic equations and how we use them, and kind of in a general sense. Today we're looking at a very specific application of the kinematic equations, and that is with free fall, okay, meaning something falling, having a pull of gravity on it. And so we could just use the general kinematic equations to solve these types of problems, and that's totally fine. But there is a specific written version of this equation that we use quite often. Okay, and this equation is shown right here, that the position in the y direction, usually we use an x, right? But the position in the y direction is equal to 1/2 times g times t squared, or time squared. So let me go ahead and label these just so we're clear on what they mean. So again, the y still means position. And we just use y instead of x because we're moving up and down instead of side to side. So we use the letter y, kind of like we do in math. Okay. T is still time. And g is what we call gravitational acceleration. Okay. And we'll look at this on the next slide and what it actually means and how we find it. Okay. But this is the gravitational acceleration, or basically how much you accelerate because of gravity. Okay, so gravitational acceleration, really long word, okay, a really long term, but it just means how fast is gravity pulling you down, okay? And so you may be wondering, well, where does this equation come from? And it comes from this equation right here, the change in x equals the initial velocity times time plus 1/2 times the acceleration times time squared, okay? So if an object is in free fall, and you think about it, if you just are dropping the object, okay, and you're not throwing it or anything, you're just dropping it straight down, there is no initial velocity. So we can just get rid of that term right there, okay. Also, instead of writing change in x, we're just going to replace this with a y because we're moving up and down. And then last of all, instead of putting a for acceleration, because this acceleration is always due to gravity, we're just going to rewrite it with a g instead. And there you go. You see how it's pretty much just rewriting the equation that we always use, okay? But we're just writing it specifically for gravity, okay? So again, this isn't a new kinematic equation. It's just a rewriting of a very general kinematic equation, okay? But we're going to use this one a lot, so we want to write it down like this because we are going to use this all the time for gravity, okay? So let's talk about this g right here, okay? G is the gravitational acceleration, and it's equal to 9.8 meters per second squared. That's a typo. Meters per second squared. Okay? And so any object, okay, that is being pulled by gravity on the Earth is going to be accelerating at 9.8 meters per second squared. Okay? So every second it's moving 9.8 meters per second faster. Okay? And you may have heard of like that famous experiment with like Galileo on the Tower of Pisa, and he drops both objects and they hit the ground at the same time. Okay, he was the one that actually figured this value out. Okay, I think he approximated it as just 10, but he basically came up with the idea that everything falls at the same rate. It accelerates at the same rate. Okay, and we can measure that this rate is at 9.8 meters per second squared. Okay, so for any free fall equation, any free fall problem, we can just plug in 9.8 meters per second squared. Okay, and use that as our acceleration. Let's go ahead and try a problem with free fall. Okay, so let's say a cliff diver jumps off a cliff and it takes him 4 seconds to hit the water. How tall is the cliff? Okay, now we're going to do what we did before in the last podcast or the last lesson, where we identify what we do and do not know and what we're looking for. Okay, so we do know the time is 4 seconds. Okay. And that's about it, right? I mean, there's not a whole lot of information given this problem. And we're supposed to know how tall this cliff is. Okay, so we're going to use y for how tall, right? Because this is going up and down. And you think, well, that doesn't seem like enough information. But keep in mind, we also know that g is always 9.8 meters per second squared. So this turns out to be enough information because we just say, well, y equals 1/2 gt squared, and we are looking for y, we know g, and we know t, so we can just plug everything in. Okay, so 1/2 times 9.8 times t squared You plug that into your calculator, and you'll get that that cliff was 78.4 meters tall. And there you go, simple enough. Okay, so we can still use it the same way as other kinematic equations, but it turns out all we really need is the time to figure out these problems. Okay, if we have the time, we can figure out how tall something is, how high someone fell, or how far someone fell, okay, with these free fall equations, because the gravity is always the same. Okay, let's try another one. Okay, so let's say a man drops a penny off the Empire State Building. If it falls for 8.8 seconds, how tall is the Empire State Building? Okay, so again, we know that the time was 8.8 seconds. We know that the gravitational acceleration is 9.8 meters per second squared, and we're looking for y. Okay, so we just know that we're going to be using this equation, y equals 1/2 gt squared. We plug in 1/2 times 9.8 times 8.8 squared. Okay, you put that into your calculator, and you get that the Empire State Building is about 380 meters tall. Okay, so there we go. So very simple equation to use, can help us solve a lot of cool problems with physics. Okay, let's look at a slightly different scenario with free fall though, and this is often the case with projectiles and things like this. What if you have a question where it's not just straight dropping, but someone throws something up in the air first? Okay, so like in this one, a child throws a baseball up in the air. If it hits the ground in 6 seconds, how high did the baseball go? So this isn't just a straight drop like we've been doing. It's actually going up in the air and back down. Okay, well, it turns out we can think about this type of problem with half the time it's going up in the air and then half the time it's going back down. Okay, so half the time the projectile is going up into the air and half the time it's going back down. And so these two trajectories, going up and going down, are actually mirrors of each other. And so we can use that to our advantage. So in this problem, it says it takes a total of 6 seconds, but it's really only falling for 3 seconds. Okay, because half the time is going up, half the time is going down. Okay, g is still 9.8 meters per second squared. And we're still looking for y. How high did it go? And so if we divide by 2, take half of it before we start the problem, then we can do it the same way. So y equals 1/2 gt squared. Plug in what we know. Again, using half the time. You plug that into your calculator. And you get 44.1 meters. And oops, I just realized that's supposed to be 9.8, not 4.9. Okay, yep, so 1/2 9.8 times 3 squared gives you 44.1 meters. Okay, so there we go. So still use the same equation, still the same type of problem. You just have to divide the time in half before you plug it in. If it's going up, then back down. Okay? All right, and now there's just one last thing we want to be able to do, and that is we want to be able to figure out how to solve the problem if we're looking for the time instead of the distance. Okay? So like in this question, a squirrel jumps off a cliff that is 100 meters tall. How long will it be in the air? This time we know y is 100 meters. We still know g is 9.8 meters per second squared. But this time we're looking for the time. We don't know the time, we're looking for the time. Okay? We can still use the same equation, 1/2 gt squared, but we have to solve for time before we plug everything in. Okay? So let's see, we can bring that 2 over here, times by 2 to bring this over here. So 2y equals gt squared. Okay? Then we can divide by that g to get the t squared by itself. So 2y over g equals t squared. And then the last step is to square root both sides to get the t by itself. So we get the square root of 2y over g equals t. And there you go. That solves for the time by itself. And if you want, I'm okay if you write down this equation separately because we do use it a whole lot, okay, for these types of problems. Okay. So if you want to rewrite it with the time solved, that's fine with me. Okay, but now the time is by itself. We can plug in what we know and get or find the answer for the time. Okay. So what we do is we do square root of 2 times 100 in this case over g, which is 9.8. And if you plug that into your calculator, square root of 2 times 100 divided by 9.8, you get that the total time that they were in the air was 4.5 seconds. Okay, and there you go. So when you use this equation, make sure you put this carefully into your calculator. Make sure everything is in the square root. Okay, everything is underneath the square root. Sometimes people just do the 2 and the 100 and they forget to do the 9.8. Okay, but this whole thing square rooted will give you the time of the free fall. Okay, so there you go. Those are the two types of problems: figuring out how high something is or how far someone fell, and then the time it took for the fall. Okay, and it just depends on what information is given. Okay. Lastly, I won't go into too much detail, but keep in mind you can use any of the kinematic equations. So for example, this problem, you have to find how tall the building is. You'd use the same equation. But then it asks what speed was it going when it hit the ground. So you can still use the other kinematic equations that we have looked at before. And in this case, you'd want to use the final velocity equals initial velocity plus acceleration times time. Okay. You can still use this equation. You just have to know that the initial velocity was 0, your acceleration is g, and the time was 7. So just keep that in mind. Again, the free fall equations aren't separate. They're just rewritings of the kinematic equations. So if there's ever a problem that you don't know how to solve with the free fall equation, you probably need to use a version of the kinematic equation. You just treat it the same way. Okay? But there you go. That's our lesson for today. Make sure you do the homework, Kinematics Practice 3, which has the free fall equations in there as well. But hopefully that all made sense. Let me know if you have any questions, and thank you for watching.